My group did better.
Right. So good afternoon, everyone. Today we have a special guest, Darwin. Darwin is a alum from executive program in here at Booth. I guess you started in 2013.
Yes.
So Darwin has done his undergrad at Purdue. He has a degree in mathematics and computer science, and then he also has a master's degree at from Purdue as well in computer science. And now he's a partner at Good AI Capital, which is a VC firm, and he has led a number of different companies to an exit. And he's here to tell us a bit about how AI can do good in the world, not just serve advertisements to people. And so I'll leave the floor to Darwin. And if you have any questions, you should feel free to ask him at any point.
So how can I control the slide?
So we can use this clicker. So that's right. It's working.
All right, cool. All right. Hi, everybody. Welcome to I guess to Miladen's class. It's a great class, and also thank you for coming here. So excited to be. Is the camera okay?
So anywhere here.
Okay. All right. All right. Okay, so let's do this again. So I think it's great to see everybody here. It was really a exciting experience. As I was just telling that Miladen that I haven't been back on the campus for more than 4 years, and due to this pandemic. And when I walked out from here last night, I was so excited. I can remember O'Hare back and forth. Like where's the bathroom, where's the bar, as part of the executive program is I have to travel here once every 2 weeks. So, I know O'Hare back and forth here. And I was just excited. And the first thing I see is that bar that we hang out. And then it's like, okay, this is still there. And I'm just so excited to be back here in Chicago. Today's topic, I'm going to talk about, I think, some of the most exciting things that's happening in AI. Of course, everybody talk about ChatGPT. And I like to kind of bring a little different dimension to what's it is other than the bus itself. I want to kind of see how that general AI applications can be applied towards healthcare. And this is actually, what we're interested in. We invest a lot of companies in healthcare, particularly. So, and we'd love to spend a little bit of time to talk more about it, in the future if you find that interesting. Okay, cool. So a little bit introduction about our firm, Good AI Capital. So we're Good AI Capital. We're a venture fund. We focus on early stage AI companies in fintech, healthcare, enterprise software, robotics automation, kind of just a whole spectrum of different kind of industrial applications. But they tend to focus on the AI aspect of it. So we have an interesting name. So we call ourselves the Good AI Capital. The good really stems from the fact that from our investment thesis, we focus on what we call a mission-driven investment thesis. We plan to do, we're very keen on doing well by doing good. And I'm sure a lot of you are aware of that kind of like tagline a lot. But we actually kind of integrate back into our investment process and as well as our investment thesis. So with that, we invest in technical founders who are keen in applying AI technologies towards solving some of the most challenging problems faced across different industries. So a lot of you must have heard about the term ESG. And ESG investment stands for, as you know, environmental sustainability, social responsibility, and corporate governances. So to a lot of people, or to a lot of investors per se, they tend to look at ESG investment as a asset class, if you will. And by that, meaning they're very interested to say, I'm very interested in climate change. I want a very sustainable energy. So therefore, I want to invest in a company that are just focusing on, say, a new battery technology, for example. Or on the other spectrum of kind of like the investment spectrum is that people tend to say, well, okay, that's good. But also there's another class of companies that I don't want to invest. For example, the tobacco company, maybe even the oil company, because potentially it's going to cause damage to the environment. Therefore, I don't want to invest in those companies. So that kind of becomes driving sort of like the investment decisions and therefore the process of some of these investors. And for us, we kind of take a different approach. We kind of look at ESG as a set of beliefs or a set of values that we want to kind of execute upon. So therefore, we want to look for teams that want to share the same values in building their companies. So I think one of the idea, going back to our investment thesis, doing good, doing well. So you have to start by doing good and then end up doing really well. And doing well in a way means that not only you can have that impact towards the society, cure cancer, save the environment. At the same time, you want to actually generate profits. So we're at Booth with a business school here. So profits is still the paramount requirement. And that's actually, we kind of integrate that investment values towards our entire process. This defines how we hire people. This defines how we invest, of course, we talked about that. And we also define like basically how we operate as a fund. So in a way, they actually kind of put it into the entire process. So that's kind of, we got our differentiation against some of the more general ESG investors or investment in the industry here. So lastly, I want to talk about our kind of last leg of differentiation. So we have what we call a lot of commercialization experiences. And what that means is that we partner with some of the leading research organizations and universities, the tech transfer organizations, basically to kind of commercialize and turn their IP into product. Commercialization, if you've never heard of the term, is just a fancy way of turning that thing let's turn that into a product and make some money. That's actually the whole idea behind it. But a lot of like academic institution or research institution, they tend to just focus on the IP generation, which they can have a great papers, they get some research, but it's never turned into a product, let alone turn into a company that commercialize that product. So this is what we want to do. We want to add value by not only just becoming an investor by providing the capital, but also become part of the founding team, if you will. So we have a lot of experiences. My background is an engineer. My other partner is also a scientist. So we have a lot of entrepreneurial experiences. And this is where we think we can add a lot of values to what some of the startup companies that we invest in. So this is a kind of like a dialogue that I would like to happen. I'd like to see happen. It doesn't happen. A couple of weeks ago, I was, feeling a little bit under the weather. So, basically I have to call my doctor. So I try to see if it makes sense for me to come in. So the idea is that, of course, under COVID, everybody was kind of like, should I, do anything differently? So I had tested negative during that morning, but I've been coughing. So I just had to kind of call in and say, should it make sense for me to come in to see the doctor and all that? So on the right-hand side, it's actually a human, but right now I have put a little logo. That logo, if you recognize, is actually the ChatGPT, the OpenAI logo here. So just pretend that that's actually ChatGPT on the other side. So on the right-hand side, it first greeted me. They said, well, they said there are many things that can lead to a chronic coughing. Even though you have negative results in your COVID, you may still have COVID. You just don't know. So it's better for you to come in and have that cough checked out. And also one thing is, if you notice, if you read the fine print a little bit, I put down actually, so this is a doctor or a clinic that have a history. So they said, they look at my records. They said, well, you do have a high blood pressure. And because of that, you're at high risk of, COVID. The symptoms can be more severe. And, so the idea is that definitely you want to have to come in and check out based on those records, historical records, if you will. So I put down, so Dr. Altman has an opening this afternoon. Would you be able to come in at 2 p.m.? So basically just say, well, just do a scheduling. So of course, nowadays people would say, oh, I don't want to just schedule an appointment with my doctor. I can fire up my app. I can just give them a call. So what's so special about this, right? So if you look at that, but that dialogue actually, if you think of it as a pure kind of ChatGPT without a human loop in it, that's actually pretty amazing. It's already looked at some of give the initial diagnostics of my kind of symptoms, and also potentially give a potential prescription, if you will. Not that it would just say, well, other than you take these drugs and all that, but in a way, it's kind of like the first consultation, which is very, very, to me, it's pretty good if they can do that. So here's another call that happens a couple of days ago. Not a couple of days ago, I mean, a couple of days after the initial call. So on the left, I said, well, too bad, I was tested positive for COVID this morning. And by that call, I was actually already I already visit the doctor to check out the cough. I do actually have that cough checked out. And the doctor said they actually turned out to give me some prescription, some antibiotics prescription. As you know, antibiotics is not for COVID, but just for general potential coughing and all that. So basically, it's just that. But there's new development, which is tested positive in COVID. So, and I go back and talk to the ChatGPT, hopefully, and give me some further kind of recommendations. And then said, well, I saw that Dr. Altman prescribed some antibiotics for the coughing and all that. But you're tested positive with COVID, so it might still make sense for you to check in with the doctor, basically communicate. So I think it makes sense for you to have it now that we know that it's not the COVID, it is really the COVID that is driving this. And again, immediately try to do a scheduling. Well, Dr. Altman have another opening today, where I can schedule a virtual visit with a practitioner with 3 p.m. work. So basically just like, have that kind of like contact or follow up, continuation. So you can see that this will be a great feature to have if it, actually have this kind of like dialogue that happens. So all you hear right now from ChatGPT, the way you look at it is like, well, it's so great. They can write essays, they can write code, they can write jokes, they can write movie scripts, they can pretend to write a Shakespeare play and all that good stuff. But those are not necessarily applying towards something, that is actually to the healthcare industry, for example. What if we can actually do that and actually ingest some of the data that is coming through that particular industry? Isn't that would be great? So this is actually sort of like a movie play, a prologue, if you will, the movie screen. Well, this is what's going to be happen in the future. And I want to introduce a concept called precision medicine. GPT, the idea is it's going to play on GPT, of course, to generate pre-transformers. but the precision medicine is kind of like the name before the PMGPT. And I would be so bold to say this will be the future of medicine. So a little bit definition of what precision medicine means. So the idea is that really, we tend to, when you go see a doctor, you would just say, well, here's some pills, here's some drugs, potentially will help this cough. It's kind of like those drugs are more like a one size fits all, The idea of precision medicine is that really tailoring the treatments or the therapeutics, drugs and all that. It doesn't necessarily just kind of restrict to drug, but also like, how you treat the patient during the journey of that, patient's journey. That become like a very personalized experience and also a personal prescription, if you will. So basically your patient's profile, and that's kind of like the general trend of saying, how can we prescribe, the right medicine for this patient at the right time? And there's another term for precision medicine. It's called personalized medicine. Some of you might have known this term already. Basically, it's the same idea as I personalized medicine towards individual patients. So I've given some examples of what that potentially means. So on the kind of like left-hand side, there's a little diagram that I draw up. So at the center again is this ChatGPT, the whole concept, this chatbot, AI in the middle. But on the surrounding, essentially is a kind of different type of data. So data such as, most obvious, your electronic health records, you've seen this doctor like 5 times already, you have a high blood pressure and all that. So this is a part of the data, right? And of course, when we go clockwise, you will see the ECG data. Potentially, that could be your Apple Watch. Apple Watch can measure your heart rate and all that stuff. You can actually collect that data. And I have this thing called AlphaFold, which I'm going to talk about a little bit later. It's one of the most advanced, groundbreaking life sciences development based on AI in the last year, if you will. So I'm going to talk about that a little bit later. And then, of course, the keep going will be the MRI, X-ray. You go take an X-ray. You have your data, your MRI imaging, and all that. And then the last one is genomic sequencing. Basically, our genes. Some of the DNA sequencing. So basically, that basically defines how our DNA works and all that. So all that kind of combined into an aggregate model. So and what that does is that basically ChatGPT in a way can aggregate and consume all this different data and build up what we call a foundation model. A foundation model in a sense is just like a aggregate matter data that will actually contains various cross references, from all this different data. So I put down some of the current limit, kind of like a current state of what we call the precision medicine. I call it current modalities. Modality means it basically just like a way of treating, patient, right? So it could be vaccines, diagnostics, gene and cell therapy. Some of you may have heard of it. And of course, some of the more consumer focused, the mobile app for basically managing your diabetes management and all that. So these tend to look at different types of treatment or kind of like tools for patients or doctors, but they're kind of consuming data from a single source of data, from, all these health records we talked about now. So the idea going back to say how ChatGPT is kind of like, now no longer we just being limited to one source of data. How about we can actually aggregate them together into this foundation model and create even a better treatment or a personalized treatment. So I think, a great example is something where someone I just showed, in my first dialogue where I talked to, this ChatGPT where they can look at my not financial records, but the health records. Potentially, they can even look at nothing limit from my previous MRI data and all that to kind of create the initial set of consultation or, diagnostics, if you will. So, so something that actually will be very helpful for both doctors, not only to the patient itself, because the doctor is still the final kind of prescription or the treatment process is still need to be controlled or managed by the doctor. But, if they have these tools that allows you to kind of come in and look at all this data, isn't that great? So, it doesn't have to be limited to say, the better can do a better job in actually doing this kind of treatment, right? So therefore, and I think this is actually one of the most exciting thing, at least that we are seeing right now. It's going to now call it the term PMGPT. This term has not been, I don't have a patent on it yet, so I may be sued on this soon, but at least this is the first time you hear from me here. So okay. So a little bit background about ChatGPT. I think so. A lot of you must have been exposed to it and then say, wow, this is so cool. How does it work? So to kind of put down into a more layman level, if you will, the idea is that really they try to use this idea basically at this, it's a great quote that's actually from Ilya Sutskever, basically is a chief scientist for OpenAI. They said the underlying idea of GPT-3 is a way of linking intuitive notions of understanding of something that can be measured and understood mechanistically. And that is the task of predicting the next word in text. Basically try to help you finish the sentence. You might hear something very interesting where, oh, we're buddies, we hang out with partners, basically finish each other's sentences. You see this kind of thing. So basically you have what that means is that you understand your partners or the other people very well. That's why you have this kind of close relationship. So in a way, ChatGPT is trying to do that. They understand so well of what you try to do, and therefore they can finish your sentence. That's in a way, that's how they want to build the architecture is built. So this is actually built upon this architecture called GPT stands for Generative Pre-trained Transformers. So it's a neural network. It's a deep learning network. So basically it's another very, very popular AI technology, if you will, that has allowed a chatbot to basically to guess what the next word in a sentence. So that's kind of like the high level description of that. So of course, one may ask, doesn't this exist already? There's like all these different, translation framework and Google Translate and all these other things that are in there. So there's a lot of these existing kind of AI technologies based on this neural network technology called recurrent neural net. You might have heard of it. So the kind of the difference that between transformer architecture versus the RNN of the world is that, so RNN essentially processes the sentences in a sequential manner. And what that means is that, let's imagine that I'm doing a translation, let's say between English and French, right? So as some of you, if you know French, so even though they're very similar language, the wording, the context, and also the entire paragraph, what it says here, you cannot just do it just a keyword kind of trans mapping, if you will. So, and that tends to be sort of like, existing new recurrent neural network where basically they're looking at each position. This one should be the same French word for a television, which should be mapped to this one and all that. So basically, that's kind of the strategy. And that kind of lacked the focus on that context and also the sort of like I would say the language context, if you will, based on how you do that translation. So basically, transformer architecture will allow to address that. And they have a unique architecture that actually allows you to look at the text in a large voluminous context. So let's say if you want to translate an entire book or something that's of a large context. So you really need to look at the entire context in order to look at what's the right translation in order to generate that. So, and that's part of the training process. In order, you might have heard, in order to do an AI network or a neural network, there should be like a training. Training basically look at the past data in order to create a model so that you can generate this model to predict what the next outcome would be. So that's kind of like the overall strategy of an AI model here. The third kind of bullet point that I put there is like, so ChatGPT is built on massive amount of data, terabytes of data, and 135 billion of parameters. And so some of you may be aware what is a parameter means. So parameter essentially, I think even in some of the more traditional AI model, regression model, and I think in this class, I think Milan has probably talked about quite a bit of that on that. The more algorithm are like basically parameter driven, meaning think of like you should try to recognize an image on a you want to say if this is one, decide whether this is a cat, for example. The way you want to do that is that each parameter you can represent is using actually the pixel value of each that graphical images. And from there, you've seen enough cat pictures, I've seen millions of them, and then you kind of detect, the brightness, the edges and all that. That essentially creates like your parameter, if you will. And that actually, create the idea, well, I've seen enough. I've said that parameter will give me that kind of like, opportunity to decide what the next path would be. And that would allows me to detect whether this is a cat image. So in a way, so ChatGPT do the same thing, except that they're using for text and all that. And then they have 35 billion of parameters. And what that means is that some of the existing algorithms out there are not even able to handle this. And this is actually what the kind of transformative, nature of it. It's an interesting called transformer, but actually it's a very transformative technology, if you will. And by the way, if you kind of want to dive in a little bit, actually the transformer architectures actually came out as an open source from Google. As you see all the fights going on, and Google is behind Microsoft and all that. But people were saying that, Google, how can you let this open source to somebody and then now you are left behind? So this is actually something interesting to talk about. And finally, this is like, basically, this whole kind of training process and allows it to let GPT become the master of these different languages. It's a talk about natural language. So in AI, you might have heard of the, another kind of like technology called NLP, which is natural language processing. In other words, it's actually using all this like recurrent neural network and all that. But basically, that broke the mold, if you will, that allows ChatGPT to become this groundbreaking technology that comes out. So I put a little link at the end. So that link will actually do a little better job in terms of explaining the technical details. If you have some engineers here, if you want to dig deeper, you can download the source code and all that if you want. This is all like I would let you can do that. And here. Okay. So I want to talk about this. So AlphaFold. So one of the interesting about AlphaFold is one of the most groundbreaking AI discovery technology that are coming out probably in the last year, 2022. You might have just kind of the media headline to say ChatGPT this and all that, but there's a little thing called AlphaFold. So what is this here? So essentially, in biology, there's a problem they call protein folding problem. And what that means is basically just try to figure out how proteins are being translated into a 3D structure. So as a lot of you may know, proteins is very important, is important to life. And having that structure or knowing that structure is actually will be key to understand how protein works. Okay, and if you know how that particular protein work will actually even more potentially is like allowing us to say potential some of the disease actually can be caused by that, misfolding, if you will, or how it's actually end up there, then you actually understand the journey of that development. And therefore, you can actually potentially have the diagnostic or intervention, if you will, before a certain treatment, a certain disease can take place. So going back, this is actually what we call a 50-year-old grand challenge. So there's a prediction that you can actually look at, this 3D protein structure. If you understand that, that would be great. So there's a hypothesis that if there's a way for us to figure out what all the structure is, this is going to be great. Unfortunately, it got stuck for the 50 years. And the reason behind it is using a lot of what we call introspection, microscopy introspection, basically looking at imaging of the protein of the cells in order to decide what it looked like on the structure. That hasn't panned very well. The technology, even though it's very expensive, but it's still not generating the result, yielding the results that they desire. And here comes AlphaFold. So what AlphaFold does is actually, of course, they use a different kind of strategy, if you will. And a lot of you may know that proteins are made up of amino acids, chains of amino acids or sequence of amino acids. So what if we can actually say, look at, what are the potential amino acid sequences? And from there, create a AI model, train it on the amino acids, and then create that AI model in a way to create that, predict that 3D structure. So, you go through, we talk about that example where we want to use the cat image. Essentially, they're using the same the same strategy of a neural network, where they say, well, let's look at some of the amino acid sequences as a training model, if you will. We create this enough pipeline, and then turn out that DeepMind has done a really good job. So they proved that actually, so in AI, if you learn the machine learning class, there's an idea called backtesting, right? So the idea is that now this is happening. Let's go back into the backtesting, feed into the model to see if it's actually generated a result. And they have this kind of idea where they actually were able to map the existing discovery and, even better, for some of the existing outcome. So that's why it was such a groundbreaking discovery, if you will. And I think I talked about that, some of the diseases is actually caused by basically the misfolding of the protein structure. So one of the example I quote is in Alzheimer's, which is an uncured disease. There's this kind of like protein called amyloid. So amyloid is a buildup that usually found in the Alzheimer's patients. There are drugs that are being, kind of like approved right now. It's a controversial debate, but some of these drugs say, well, we can actually reduce the buildup of this amyloid. So that's actually the after the fact. And then amyloid, in a sense, is actually attributed to the misfolding of that protein towards like this become this amyloid. So in a way where, let's say, instead of just treating after the patient having this, what if we can actually predict whether a patient, because of this potential amino acid structure where they have a risk of, even getting to creating this misfolding structure. And what if there's a way we can intervene and potentially cure that disease before even it happens? So that is sort of like really, treatment and the promises that are available. And that's something, although, this is, of course, this is just very, very beginning, but that's actually signals a really great potential in some of the most difficult diseases, that are out there that are still uncured and all that. And also that I'll bring an example too. So enzymes is another kind of used to break down some of the industrial waste. And how can we actually use potentially create protein that map the enzymes? So that in a way, that also create a groundbreaking opportunity where we can actually address some of the most challenging, difficult problems that are faced across the world right now, right? So one very interesting thing that I want to point out, so AlphaFold is also using a transformer-based neural network. So you would say, wow, how does that happen? I thought all this transformer is about words and all that, right? So I want to kind of picture for you to drive the picture and say, now, instead of words and sequences, look at amino acids, protein, DNA sequences, how they kind of connect with each other in that 3D diagram. So basically, I have that little thing on the left-hand side. This is usually I like to show that because it's a 3D kind of spinning structure, but this is a protein structure, if you will. what if we can actually look at all the nodes, consider all that nodes in that, amino sequences is essentially kind of like a word. And what is the relationship to the next word? Or even to the entire sequences, which is like could be huge, right? How can you look at that? So remember I said that the transformer architecture allows you to look at this large context, large, sequences of data where it's not looking at just like, one particular. So that architecture is called transformer-based, attention-based architecture. Essentially, it's being applied to do this kind of like discovery. So there you have it. So it's not just about, ChatGPT is cool, but I think it's even cooler. Okay, so this is a picture that I took a couple weeks ago. So the title is that, so what's next? I'm not, obviously I'm not in the healthcare industry, I might not be able to do a lot of stuff that you talk about. But what can I do? What's the kind of next opportunities? So I kind of coined the term that there's a vertical AI. So I did not, again, it's not me that is, kind of coining this term. So this picture here that I took is a couple weeks ago. Some of you might have recognized the gentleman on the right. His name is Sam Altman. So remember I said Dr. Altman. So Sam Altman is the CEO of OpenAI. He used to run another accelerator called Y Combinator. Some of you may have known. So he's the CEO founder of, OpenAI. I had the privilege to attend his talk in person. So at the end, of course, there's a lot of talks about, okay, so, is Elon Musk going to destroy Twitter and all that stuff? They'll talk about all the different stuff. And then at the end, some guy walked up and asked a question, say, so Sam, what's the next opportunity in AI? Now that OpenAI is dominating the industry now, right? Should I even bother to start another AI companies and all that, And then he said that, well, there's a lot of good opportunities. And they would tell, basically, go start a company built on vertical AI. And what that means is that, what does that mean? So remember, I think if you look at ChatGPT, it's actually consuming data from the entire internet, public internet that is accessible. I'll also give an example at the beginning. But ChatGPT cannot do what I just tried to describe at the first dialogue, right? They don't have historical records, the health records, they don't have the patient's data and all that stuff. What if we can create a healthcare or PM precision medicine GPT to leverage that and build applications for that particular industry? And that's where the opportunity lies, right? So, and even it comes out from OpenAI's CEO, that meant a lot, because that's where the opportunity. So as we kind of know, we are at what we call a commodity. Technology can be a commodities kind of space. AI, of course, now you're ChatGPT, but you never know, next month you might have something new, right? So the idea is that what if we can kind of leverage the technology, but build on industries using the industrial data that actually can provide the values or the benefits for those particular industries. OpenAI is not going to do that. Google may or may not do that. Microsoft may do that, but they are not necessarily focusing on that right now, right? So, and that's where the opportunity for entrepreneurs, that says if you have that desire to kind of create something innovative, this is an opportunity. You are not necessarily going to recreate the next version of OpenAI ChatGPT. Perhaps you can create a PM GPT. You can create a agriculture GPT. You can create a manufacturing GPT. You can create a finance GPT, a banking GPT. All that, I think it's just, to me, it's very exciting and actually resonated very well when he said that. So, and this is actually why I want to put up this slide here. So I think healthcare is just one very nascent industry where we can take advantage of this. So now is what's the next step, right? So this is, so there are two things that I think will now, So what is the competitive advantage now? Let's say if I want to build a startup on this, PMGPT, right? So any startup, so as we know, data is kind of like the driving force behind this AI model. The more data, the better data you have, then you create a more powerful model, right? So we see that we can do it from healthcare industry, from just the public ChatGPT. So if you have company that have access to also what we call proprietary data, then that instantaneously create your advantage. Let's say if I have all the MRI data for my patients, I try to do a early detection of breast cancer or something, right? So at that potentially, then that become your kind of like moat, if you will. This is your differentiator, your capability. Now you can always license the technology from OpenAI to do that, but your capability is really limited to your the access to us to data. So I will put down this like the two potential way you can do that. Of course, through business partnerships. If you can actually have different hospitals, clinics, resources that you can tap into, that become your competitive advantage. And there's another interesting thing I want to kind of mention here. You might be able to generate your own data. So some of you might heard of the idea called synthetic data. And the idea behind it is really say, well, instead of actually relying on real patients' data, I can actually mimic or simulate to generate some of the data. And I can talk about this a little bit, in one of the companies that I invest in, how we do that. But the idea is that, you might have heard the term, data is the new oil. People talk about that a lot. People talk about utility, electricity, and all that. So data is the new oil. So why do people do that? Because the data becomes your competitive advantage. It's being shown up here in this discussion here. So that's why I want to bring up is this slide. So I'm going to talk about a couple companies. Let's see. How much time do I have?
I think I allocated half the lecture for you. So.
Okay.
You have like 45 minutes, but maybe allocate some time for questions.
Okay, 45 minutes. Okay. So right now, I still have 45 minutes?
Yeah.
Oh, okay, good. Okay. All right, then I can talk a little bit more. And hopefully I've scheduled some questions. Okay, so this is one of the company that we invested in. The company called Vast Biomes, and wrote an article. It's called From Bugs to Drugs. It's kind of interesting. So some of you might have heard of the idea called microbiome. Basically, microbiome is a kind of fancy word for saying your gut bacteria. You might have heard of that gut bacteria. So the gut bacteria, in a way, in our stomach here, actually has a little bit of healing power, if you will. A lot of you may not have known. So the idea is that what if we can actually stimulate some of the effect of some of the microbiome capability and try to say potentially create a cancer healing drugs. And that's actually what this company is trying to do here. So you might have heard of like the idea called prebiotics, your kombucha, and postbiotics. Essentially, these are all kind of things, commercial products that you'll hear that say, how can I make my gut better, to improve my gut bacteria. So basically, we know that there's a lot of potential in that. It's just that we don't know how. And then some of the benefits, people might say, oh, the more this kombucha you drink, you're going to be more healthy and all that. I don't want to say it, but it's not necessarily true. But it's just the idea behind it. But there's actually a lot of health benefits potentially. Now we actually take a scientific approach to do that. And it's more interestingly, this is actually taking an AI approach to do that. And how does it do that? So basically, knowing that the fact that some of the profile of the microbiome or the patient who has the microbiome that has this potential kind of like outcome that you would see. Maybe they said they have we respond better to a clinical trial for a cancer drug or something where, so from there, they kind of take that profile. And then from here, they will just kind of like go back and then feed into this kind of AI model where let's look at sort of the genetic makeup of what this profile means, right? So at the end of the day, all the cells, they all make up, but they all break down to the genetic sequences here. How we can actually go all the way back down to create this model. So in a way, so you create these guys that create this AI pipeline in a way where basically training model to say, let's see all this profile again and again and again and again, enough to build up this AI model to say, look, I've created this model finally to say, look at this, some of the 2 million parameters, and by parameters, it could be the sequence of actually that microbiome makeup where now potentially this could be a drug that we can manufacture potentially. And let's just go back what we call sort of like reverse engineering way, if you will, and then go back and say, let's make up some potential drugs that are potentially that can align with those genetic makeup. And there's kind of like a potential, treatment process and all that will allow you to advance that process. So why do I talk about this company so much? First of all, it's I think it's a great company. I always want to show, instead of the logo, I want to show the founders. These guys are actually what we call, very mission-driven founders here. They're from Google, Harvard, and Johns Hopkins. And one of the most important thing is that where do they get their data? These guys have a partnership with a hospital, actually research center in Texas. It's called MD Anderson Cancer Center. Some of you might have heard of the most well-known cancer research hospital. But that data is coming out from there. And remember, I say that what is their competitive advantage? Because these guys are, they strike a partnership with these guys here. They say, well, we know there's a potential benefits, but we're building this AI model and we'd love to have that data. Can you help us? Of course, there's like a partnership agreement that allows them to say, well, it's not like just like everything for free. Everything has to be kind of like mutual. There's will be some milestones that we can actually potentially some of the IP or the outcomes that you discover can be part of the IP for MDN. So basically, the idea is that how you build that kind of like relationship is via this partnership deals. And actually, then one of the things that that really kind of like differentiate these guys as opposed to say, everybody's I come out and say, well, I have a AI model, I can potentially detect cancer and all that, breast cancer, whatever. Great. Then, the first question that I usually ask these guys is like, where did you get your data? How you're, from other people that can also getting the data, and how's your algorithm that are potentially different? So, and a lot of the companies or the entrepreneurs that I talk to, they kind of stumble upon that. They say, no, we just kind of open source somewhere and all that. Well, then you are no different than the next guy that comes in, right? So this is actually what we tend to look at. What is your business partnerships? Some of these partnerships could be even customers, and that's actually we look at that quite a bit also. Of course, in business school, you start a startup. Number one thing you want to have customers, right? And that's, of course, is, icing on the cake, and this is actually something that we are very excited about, right? So that's a great example of, data become the moat for these guys here. And of course, the AI algorithm, the data scientists behind it are also great. But, this is something where, we talked about also already. Okay, so this is another company I want to talk about. It's focusing on transforming precision medicine. So this company do a little bit something different. It's not so much on the AI side, but what is cool is that really they're doing what they call a delivery system for gene and cell therapies. So some of you might have heard of gene and cell therapy is one of the most groundbreaking, some of the therapeutic treatments for a lot of new diseases that we have, cancer and all that. So part of the challenge of some of these delivery system is that they're using what we call a population, kind of like a large population delivery, where, you know, if you have sort of like the idea behind it is to just some sort of use, I think, you know, payload potential, a drug treatment that you want to kind of go back and inject towards patients, potentially, hopefully will either correct the genetic makeup, cell structures, and some of correct the behavior of the cells. So in a way, there's actually, you have some sort of delivery mechanism. So right now is doing what we call a kind of last shot, if you will, right? So I just like blast it in. Well, I shouldn't use the word blast it, but in a way, it's actually kind of go into the patient's body, and hopefully, you know, something will work, something may not work, right? So the way I describe it sounds already problematic, as you can tell. So what would be ideal? So I talk about this little thing called precision medicine. What if we can actually deliver the payload individually for this patient? And even more amazingly, what if I can actually deliver towards each cell? You know, isn't that amazing? Where basically each cell has become a target where we can actually deliver that exactly towards each cell. And that's what this company does. This Mykonos is actually trying to do that. This is actually a hardware platform. As amazing as how to describe it, it's actually, think of it as a semiconductor. It's a chip that has multiple needles that are kind of attached towards it. And then actually the needles are micro needles, very small, and actually lower towards the device where we can trap the different cells together and actually deliver the individual payload towards each individual cells. So that's actually a kind of the gist of, like, you know, what precision medicine means. You know, we can actually deliver that individually, not only to the patient individual cells. That's, you know, the most amazing part. And you can control it, not just say, well, just like, you know, because, you know, it's not like really just stick it in there and we'll be there. There's a lot of processes, technical challenges that involve in order for you to do the delivery. And these guys solved it. So, and that's a great example of what precision medicine means. So when I say top precision medicine, it's a very broad stroke definition and all that. But now you can see if we can actually apply some of these technologies towards that create a huge benefits towards, you know, patients. And at the end, you know, it's not necessarily they're creating cancer treating drugs, but they will actually accelerate, and, you know, to do a better job in actually do that treatment. Isn't that great? I think that's actually something where we tend to invest in, focus on this. So fast forward, I think they just announced in 2022 Nobel Prize winner, Caroline Bertozzi is a scientific advisor for the company. I'm so proud that I actually invested in a company before Caroline was a advisor for the company. So that kind of go back to our initial description as to how do we pick out some of the company. These guys that came up from Stanford, the stem cell research lab, just like scientists in the lab. But the idea is that, you know, these guys have never commercialized a product. And this is where we come in here, we invest, we come in here. And based on our background, we actually, my partner was part of the initial founding team also to help out with the business development and scale the company. And fast forward, you know, these guys raised 50 million. And I like to put that quote in there. Again, it's called precision drug delivery. So Caroline put a word in her acceptance speech in the Nobel Prize, is that, so they're focusing on this idea called chemistry medicine or something. So doing chemistry inside living patients to make sure drugs go to the right place and not to the wrong place. So to everybody, that seems so intuitive. Don't you want to have to say drug go to the right place, not the wrong patient? But having heard what I just described, it's not as easy as you think. And this is what her vision is. It's like delivering the right drug to the right patient, hopefully at the right time. You know, that's a huge challenge, and that's what you want to do, and that's what this company does. So I think that's actually kind of the epitome of precision medicine. What the benefits of that, you know, it's a great example that I like to always quote. So lastly, I think I also want to talk about this. This is another great company. This is a company that is based in UK. Again, it's not so much on the AI side, but they focus on the idea of basically stem cell manufacturing challenges. So I think one of the also the paper is called what they call the Yamanaka transcription factors. The idea is really like having that configuration of stem cell where you can actually create the potential manufacturing of that stem cell where there's a lot of impact potentially where for how you do clinical trials, testing, and all that. So the reason that I want to bring this company up is that remember I told you that you can generate your own data, right? So this is not necessarily based on some patients and all that. So this is what this company is trying to do. They try to configure, if you're a lot of engineers in the room, probably they know how to write code. I need to configure my system so that I can create a certain, so in a way, they're trying to do the same for cells. They can configure the system so that they can create a cell that's a configure to the right, system and all that. And part of it, they can generate data. And using that data potentially and say, well, I've used this data and I've tried this on the potential drugs. The result is not good, for example, whatever reason. Then you capture that. And over that, basically your capability become like this is your own capability. And then potentially create a potential AI model for say, well, we've generated enough data, generate enough tests, say the drug does not respond well, and some of them respond really well, and that become your AI model or training data for your AI model, if you will, right? So then it's actually, again, going back to say, if you can have that capability to generate data, that could become a huge advantage also. Of course, for this company, the advantage or the differentiated technology is their stem cell manufacturing technology based on this Nobel Prize winning kind of paper and all that. But that doesn't limit them for, stepping into that potential business, where that could be another differentiated advantage for the company. Okay, right? So that's it. So I would, this slide I can have my contact information and also some of the links that I put in there, so you can always go back and reference it. There's a lot of technical details that might this would be too much to talk about. But whole idea is that hopefully give an overall kind of idea of how we invest in companies, how AI is being applied towards industries, and what are the next set of opportunities. Okay.
Thank you, Darwin. So I guess there's a time for questions. So you can ask Darwin.
Okay.
I can sit, right? Sure. Okay, so I'll open folks to you, Jose.
Yeah, just wondering, could you talk about an example of what a vertical AI company looks like, maybe from one of the companies in your portfolio, or like choosing a very basic industry so we can see what it looks like?
Well, I think that microbiome company is a good one. Although they're not using the ChatGPT technology, of course, but I think the premise still sticks where, because of the emphasis of having that data moat that these guys have. We all know there's a potential great advantage is a certain development or certain hypothesis. Let's prove it, right? So that's where the AI model is, right? So that's what these guys are working on. So they have this potential partnership. They have this partnership with this leading research institutions, cancer patients, and all that. So basically, that's their idea. Of course, now right after right at the release of this OpenAI. Late last year, there's a company called Jasper AI that was actually right before the OpenAI, the ChatGPT announcement. So some of you might have heard of Jasper AI. Is basically they're doing copywriting, so for the marketing. So basically, they're using the same OpenAI technology. They license it from OpenAI, but they target on the marketing, kind of like brochures and okay, of course they use other additional data as well as AI technology to. But the gist of it is basically now I can be your marketing, GPT to create the copyright materials as opposed to say, doing a nice PR release. They can actually write the entire PR release potential. That's a more straightforward one, but that's also a dangerous one because that's actually what ChatGPT does. Very well also, right? Differentiation is so right before. That's an example, but I think you can call it like the marketing GPT, whatnot. But I think that's also created a danger a little bit also. So what we tend to look at is like anything that is more involved in more industrial specific, if you will. If you have something like, an agriculture that's look at potentially, or in the healthcare, I think is a great example, right? Nobody's building this ChatGPT for the healthcare industry. I would love to, if you're any one of you entrepreneur that's building that, we love to invest in those companies, So that's something where we tend to look at, and there's so many different opportunities, it's just like that initial line of support. You can tell, when you try to contact the person, having that sort of like a doctor-like kind of experiences of, that's a great applications already, right? So, and I think that's, like I mentioned, you don't see Google and, OpenAI building that industry because, well, first of all, they don't have that data. They have to go in and talk to the clinics. They have to talk to, the healthcare providers and all that cannot use that data. So that's kind of like an example.
You mentioned that the next generation of apps require of private data, but at some sense, we are seeing that the customers are more aware of the data that they can share with the application or in the internet. So how is that kind of restriction in terms of access to private data to these new apps that are starting to?
So actually, immediately that I was planning for that question. So healthcare is the number one privacy issue, right? So it's like, great, you're sharing my, it's okay, but what if what about my Apple Watch, heart rate data? You want to share my data also? So there will be challenges, My advice or my inclination is that for entrepreneurs that want to start a company, focus on something where you grabbing the data or the relations that are both incentivized on both ends. It's not just necessarily say, oh, I go to Facebook, please give me all your customer data and I'm happy I can build this great GPT application. That's not going to happen, right? As you know, Facebook is facing these issues of the privacy data and all that. Of course, that's an extreme example. So if you go to the healthcare industry, so let's say, what if I can just ingest the data from the electronic health records? Something like that simple, right? To start with a certain initial domain. But that's kind of like, if you kind of create enough benefits or values for your customer. In this case, it's the hospitals, the clinics, and the doctors say, well, I provide basically a very nice support system with you, and it's one that is working. Would you be willing to share your patient's data as part of that? Because, they own the data in a way, they're not really sharing it. They're just actually building the startup company or just building an application that is using the customer data, if you will. So that's kind of like how we look at it. And, some of you may have worked for enterprise software company, they might buy enterprise software, you can Zoom and all that stuff, but the data is still, part of the enterprise, if you will. In this case, the enterprise will be patients and all that. So they will be more than happy. So yes, you can use patients' data, to build these applications. And there's very limited, and there's a little bit less challenges, and then, they will be more than happy to do that. And that's existing applications as a kind of precedent that allows them to do that, or that kind of applications already. I think a lot of applications are already doing. So that's kind of my advice. There's a lot of different challenges, of course. And for the great entrepreneurs, it's basically pick your battle, pick something that is actually where, you can actually leverage the most. And that's how I see some of this try to get around some of these privacy data issues here. And if Apple want to say, yo, I want to build an application on Apple Watch on my ECG data, but they might not have the capability, they might find a startup or biotechnology to build that. That's an opportunity right there, right? So, but again, we have to look at it from different angles. That makes sense?
Yeah.
Hi. So I just had a question. So it was quite an interesting shift between going from precision medicine to use the big bio. But I was just curious if you've had the opportunity to see a lot of AI, ML in biologics manufacturing, for example, or any other more advanced manufacturing process.
Yeah. So I would actually everybody knows this company called Moderna, right? The vaccine company, COVID vaccine and all that. So I don't know if you heard, they actually have a new vaccine that comes out at the end of last year. It's a vaccine for cancer. So some of you may have, I said, wow, it's a vaccine for cancer. So actually it does. Of course, it doesn't capture the headline as everybody is going through. So one of the way that they do that, of course, the technology is based on the mRNA kind of, the one that is the same, basically using a prescription kind of method for delivering the COVID vaccine is a huge success and all that. So now they're actually using AI in this case and say, well, let's look at the potential cancer patients at the genomic sequences. And from there, they want to kind of reverse engineer from there and then potentially look at how that vaccine can potentially, they call it inhibitor, basically prevent, it's not necessarily prevent the cancer from happening, it's different, it's a misnomer, it's not like, cancer, it's like a vaccine for like COVID. So basically you already have cancer, now it's like, how can we actually reduce or help treat the existing cancer patient? So what they do actually, they look at the existing patient profile, and then from there, look at the genomic sequences of that patient. And look at that, they will actually look at prescribe a potential mRNA formula, if you will, that actually map against that patient's kind of reaction towards it, using all AI. Basically like you can have what we call potential outcome manufacturing and said, well, if we have this kind of genomic makeup and I have this mRNA vaccine here, if I have that potential mapping, what would the potential kind of outcome, or would they react to it and all that? So basically, it's like become a kind of like what we call sorting, filtering, and all that kind of like large pile of data. How can we actually identify the different patterns that allows you to kind of go through what's the best potential profile, and then actually that's how they kind of develop that cancer vaccine. There's a video I can send out. So it's in a way it's manufacturing in a way for the for the drug development, but because at the end of the day you want to not just the number that the vaccine is, like the precise effect of that particular. So actually that helps in that, manufacturing process, if you will, right? So I don't know if that's actually a very interesting way of one of the examples that I see.
Thanks.
So you focus a lot on machine learning and AI. I was wondering if you also use these tools to predict maybe the probability of success of one of the companies you invest in, or the valuation. Do you actually use this yourself, or intuition is still?
I've been asked this question. If I know that if I use it and was successful, I'm not sitting in here today. Well, investment is a different game. I think there's some people who play the quant trading way, hedge fund and all that. I think It's probably another department up there you can talk to.
Say about cancer, no?
Yeah. But, for this, I think, again, I think, we want to take a different approach. I think, as we talked about, I think, having that kind of strong values is important. I think at the end of the day, entrepreneurship is a very difficult journey. It's a long, and the reason that I stopped doing investment is not only for financial outcome of it. And of course, as you kind of listen to my work, we want to have to drive the impact towards, the society. And at the end, hopefully we can make some money at the same time. So that's kind of our motto, if you will. Of course, technologies will play a smart role, some of the more repetitive tasks and all that, there's like some of the more tasks where, okay, if you have like all these different sources of, deal flow recommendation, people coming in, they would just say, how can we kind of like sort through this, right? So a lot of them is still based on intuitive. We're a small fund, we're not like the large, company, but relationship is still paramount. So I think this is something we strive to build upon. So I don't know if I can answer your question. So,
I feel like with precision medicine, there's an additional lift in the sense that, great, you have a patient, their genetic sequencing, but you have to have a drug tailored to them as well.
yes,
So that seems like another challenge.
it is. And that's why there's so much things that you can do. That's like, this is something where, and the thing is daunting, but it's actually exciting. So I don't know, there's some of you may work in the healthcare industry, have some background. In healthcare, they always say, I'm going to create this cancer drugs. And at the end, I want to do this, they call unmet needs. Unmet needs mean basically needs that are not satisfied. So I always say the entire healthcare industry is unmet needs. People are still dying, our healthcare system is still crumbling. People are not getting the right care, for various reasons, some political, some, financial, some, the scientific discovery. And that's what we strive to do, right? So having that, one thing that we can do to kind of change the landscape a little, make a dent a little bit, I think that's very satisfying already, right? So, and we're not going to be, all this groundbreaking technology, or win any Nobel Prize anytime soon for me. But the thing is, if we can actually say anything that can improve the kind of like the process, I think that would do a great deal. I think having that precise kind of delivery is one, I think, great benefits, right? And also, I want to kind of talk about some of the investment thesis behind it is for healthcare. So for the healthcare industry, I think I talked about unmet needs. It's very, the drugs itself, the typical drug development is a long process. It's 10 years, $1 billion at least. And the chances of failure are very high. The typical drug development, to the market is, and therefore a lot of these stuff kind of boils down to say, so it's so expensive, the drug cost, right? So people will say that, well, the government should be paying for that. So this is the political side of things where, I cannot tackle. But what we can tackle is that what if we can actually compress the cycle? Anything for the discovery, the delivery, the manufacturing, or just identifying the right patients, the right target, at the right time, that will increase, that probability of success and therefore compress the cycle, and then at the end of the day, we can deliver that drugs or diagnostic tools to the patients quicker, and they can afford it because, the timeline become from 10 years now has become 5 years. Then, the cost will just compress and then make it more available. So at the end of the day, I think that's what we want to do also, right? It's a very broad statement, but the idea is that if we can do all that stuff to improve any single knob, anything will contribute towards it. And I think that's a great thing that I think endeavor that will pay out, greatly because, now at the end of the day, people can access healthcare systems, whatever it's drug, whether it's a healthcare, the best provider and all that, right? I think we felt like we've done our job. So I think that's something where we feel very proud of.
Sorry, I saw that you had like did you come from like healthcare background or?
I have no healthcare background. I know nothing about healthcare.
Yeah, I mean like healthcare.
No. Actually, yeah. So I'm an entrepreneur. I'm a tech entrepreneur. I write code. I not as well as Milan, but I developed a couple AI model, as an engineer. So I'm an entrepreneur. I developed technology. One of the startups got sold, acquired, fortune. So my background is engineering, and I have the fortune to be part of this institution here. I learned a little bit about business from here. So, but I think no, I have no background. So part of it is really in a way where, going back to our mission, right? How do you do good to the society? I think, healthcare is the number one challenge, that we face. And of course, we are investing in other companies. We have a robotics company focusing on food delivery, and we have other like enterprise software, fintech company, and also. But I think, healthcare is, I think there's a lot of opportunities. And all challenges. That's why I say, this is something where we feel very committed to. And like you said, I'm not a trained doctor. I know nothing about healthcare. It's been a difficult journey for me to say, well, I like to do something in present healthcare, but I have no training. So I've been fortunate that our partners, our advisors, they all have deep training they come up with a healthcare background. So I learned, and entrepreneurs that we invest in. So they are grateful enough to teach a person like me to learn the ropes and all that. So I think part of this, my growth as a healthcare investor, if you will, is really fueled by my idea to say, what can we do to improve the world a little bit? I think that's kind of like, what drives me. So that's kind of like, my background. And I think it's a lot of people are kind of contemplating, don't let your say, well, just because I'm not a doctor, I cannot be working in the healthcare industry or whatnot. That's not necessarily true. I think if you have the right motive, the right motion, you can learn, you can grow. And I think, right now the buzz is still like, oh, let's work for OpenAI and create this, ChatGPT. That's all good. It's all good. But what if we can actually take it to the next step, right? So that's something where I feel very driven to do that, right? So, yeah, that's kind of like my.
Yeah, I have a question which is a bit less technical. I think you've already touched on this a bit, but most of us are not computer scientists.
Yeah.
So we're mostly have some strength in data science and already knowledge of machine learning. But
by the way, you have a great professor here, best class here, in here. So you're under good hands. So you might not be a lot of background, but after this class, you'll be an expert.
So my question is, I, for instance, get a lot of ideas of whenever I'm in class of what I could do, what could be done, both in policy and business. But how do someone like us, who is not that technical, get involved in this sort of business? What's the role?
Business in terms of what?
Developing an AI application, for instance.
Well, that's actually, I would say join a startup. I would say, I'm an entrepreneur, I'm an investor. So as you know, right now, I think we are under sort of a lot of macroeconomic challenges, the layoff, inflation, everything, tech companies are laying off, people. You're not necessarily better off to join a Google or the Facebook now, right? So you never know what's going to happen. So if you have some great idea, find a startup that is willing to, work with you, or maybe even, take it the next step, being an entrepreneur. This is the best time to start a company. I know I always say that, but people just say kind of some, this is not the right time to say that because just some got laid off and then you show them to be an entrepreneur. But that's not necessarily my motivation in saying that, because I think usually an entrepreneur, you have to give it the right push, if you will, where if you have the right idea, this is the right time to explore that. I don't see why you cannot. Of course, it's a difficult challenge, and it's just like, okay, find some partners that you can work with, build a team potentially, learn from others. So that's something where I would, suggest. So, but I want to caution that not everybody's to be, could be on entrepreneurship. It's a difficult journey. But if it's something that you want to explore, this is the right time, learn ChatGPT, go log in and then figure out and, try to build something, play around with it, right? That's a good start, right? And so I think that's kind of my overall kind of vague advice, if you will. Thank you. Yeah.
Other questions that folks might have?
So have you heard about Campus?
Excuse me?
Campus. That's another company that does precision medicine.
No, I never heard of it.
Okay. So I would say maybe in the future, I think this precision medicine field. As an investor, I know you've touched on building a moat that's solid in having a good data resource, have a good scientist team. Would you evaluate the algorithm?
Well, that's a very difficult thing to do. Algorithm. I mean, as I pointed out, of course we will do that, but we're more interested in the outcome, right? So, I don't know if you know, OpenAI, ChatGPT actually has been existing in the last 5 years. It kind of kept quiet. Nobody heard about it until last year. There's this kind of thing called new wave called generative AI that comes out. And the idea is that, wow, you can actually combine these pictures and create this Mona Lisa riding a motorcycle and all that stuff. This is so cool because nobody knows this stuff here. And they might say, wow, these guys have been building on using transformer architecture, neural net, blah, 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 blah. But nobody actually see sort of like, what can you do with it, right? But all of a sudden, boom, it comes out, these companies do these things here. It's a very groundbreaking way. The consumer side of the society said, now really, even the 4th grade, student can now say, oh, ChatGPT can help me do my homework and all that stuff, This is like really like, I think it's really like it's a great, you can see the benefits right up here. So for us, I have a background in AI, but doesn't mean, I know better than say your algorithm is better than the other one, right? So again, it's that the data, the outcome and all that, right? And a lot of these things tend to not as obvious at the time. So I tend to shy away with the, technical discussion, so that's kind of how we evaluate the company. Although one thing I like to point out, a lot of entrepreneurs that we want to talk to, usually they're not necessarily an AI company, but they want to kind of show off a little bit. They said, oh, we're building this, potentially medical device or pacemaker and all that, right? So, but, we're thinking of using AI to do this, but we don't have that yet. And hopefully, as an AI investor, you invest in us, you find some AI engineers to join our team and we'll figure it out. That's a pitch that I don't like to hear. I rather have people focus on the core products, core technologies. Technology is actually the second pace too. If you have a great product, I think that's the most important aspect of our evaluation also. So I guess, then kind of put down the AI algorithm towards the bottom. You're like, okay, that's to me, it's not necessarily the most important part. Still kind of just say, hopefully I build a great business with great product, with a great team, with a great market. These are the traditional stuff that we look at. And AI is just a small piece of it. If you
So trying to say, in the first place, to make a product is already.
Yeah. So our criteria look at, the three-pronged criteria for look at a startup company: product, market, and team. That's it. So I mentioned the word commercialization a little bit. Commercialization is a fancy word to say turning some intellectual property into a product so that you can sell it. That's kind of like, the layman term, but that's tend to be missing in a lot of like companies. That's like even the non-biotech or the life sciences company, they might say, oh, I want to build this kind of like, I don't know. I went to this YC, which is Y Combinator demo day. There's like 100 companies. The first thing they say, we're building this lawnmower with a Tesla of lawnmowers or something, Like they basically just do all this stuff here that kind of capture people's attention. It's like, what is exactly is your product? So that's the first question that I used to kind of like ask. We don't look at
Thank you. And so I'm wondering of course, the development and launch of this AI system requires huge amounts of like individual level data and probably a lot of biometric data. And I think that less so in the US, but you could imagine that in other parts of the world, especially the management of this data and who gets to use it and all the privacy regulation surrounding biometric information, especially, would be a source of concern.
Yes.
So I'm wondering if this is a conversation you get to have with these companies, if that's a concern in the US, or just what's the
I think it's
landscape?
the whole world. This is something where, so a little bit background of OpenAI. So I don't know how many of you might not know, OpenAI was initially founded as a nonprofit. Okay. So basically they say the idea behind it, and by the way, Elon Musk is the investor and all these guys. So they said, well, they are concerned about the AI safety of AI. So of course you heard, good things from AI, and there's a lot of bad things that are happening in AI also, right? So the deepfake of the world and all that, right? So how do you kind of do a better job in controlling that, right? So that in a way where that's what OpenAI is trying to do. They said, well, let's look at the AI safety, try to do, build a intelligence system that is actually at least, not the Google ways, like don't do evil, but, hopefully, do something, fair and non-biased way that can contribute to the humanity, really a great AI system. And by avoiding all these different risk data and all that stuff. So for us, I think, we try to adopt the same kind of model also. Again, privacy data is one issue. Of course, some data that people don't even want to share, then don't get it. Don't try to even use those. So, and if there's some company that try to bypass it and then that to us is a violation. What's that? But this is something where we don't want to invest, of course, and we don't want to be part of this. And that kind of overall, and then of course there's the regulation challenges, on the government level where some people may say some countries may be more relaxed in terms of this. And how do you deal with that? I think it's beyond our control in this case here, and also beyond some of the entrepreneurs. Maybe they don't have that. So I would reference it also like a guideline in terms like what does it do? Does it violate the privacy issues? how do you get those data, and what is the relationship behind it, and you can tell where a lot of these stuff that somebody asked me how to evaluate the algorithm. So in a way, there's a potential risk in AI where there's actually biases. So remember I talked about these little parameters. These are like, you can build a parameter to say, oh, okay, so I can look at a certain characteristics of this, kind of system. But how do you know this characteristics or the parameter is the right one to use? And that's kind of like the biases. Right? So great example, I think there's like, resume filtering, something where, people will say, oh, I want to like kind of like get the resumes for my tech company and all that. So people tend to say, oh, they want to look at the sequences of the job continuation, kind of like, history, right? So if you have like a gap year, people will figure out. So a lot of these resume, by controlling parameters, what they do is like, well, there might be women that is like, stay on the industry for a couple of years to tend to the family, so they have a sort of like a 2 or 3 years gap. And automatically, maybe those resume got filtered out because those are my biases is only look at the continuation, as opposed to say, some other factors that maybe I have, I was sick or, all these kind of things. How do you account for these kind of things, right? And that's how you build the AI systems. You can build an AI system that eliminate that, or maybe you can explicitly put that. So that's where sort of like a, I would say something you can control as a engineering, as a startup company, where you can actually, this is something not necessarily this algorithm per se. It's actually how you build a system itself, right? So I think that could be a lot of poses as an opportunity, as well as, we can call it a risk, but also as also an opportunity. Well, how can we kind of like de-bias? There's also a system that allows us to do that, right? But that's kind of one way into that problem.
Other questions that folks might have?
I guess another question would be, well, I guess you had more like classical, like computer science background. So how do you think, I'm still a CS student, I'm in college. So we've been taking lots of like architecture level stuff, like very foundational network, operating system. How do you see those evolves, over the time with these kind of technology, and how those things will support it, or like any opportunities you think there?
I think those still will remain. It's a critical skill sets that you need to build upon. I think but yeah, I think in a way where so the now sort of like the way I look at it is that instead of building the foundational systems again, I'm not going to build another operating system, right? I'm not going to build another like network router and all. Those are already built, right? But you need to have the understanding of how these things work and apply that knowledge towards, how can we potentially build a product that are leveraging what is foundational system. So AI is to be another foundational system. So now you have basic understanding of how your random forest, algorithm works. How can we use that kind of like data? And now you have learned a little bit about how your network works and all that. You're not going to write the next neural network or recurrent neural net or the transformer and all that. But what if I can actually build an application on top of it? Now that requires not just the transformer itself, right? Now you can say, well, I need my, programming language skills. I need to know what's the coolest language now. I don't know even Python or what first. Rust. Rust. I don't even know what that is. I haven't been kept up, right? So, but these things will keep going up. You're not going to keep up the latest, latest languages, whatever web framework or mobile app development environment. So when I learned, many years ago, I learned still stuff that still sticks is probably my operating system class. I still remember we built a kind of mini operating system, but but I don't need to know how the iPhone is being had now, but I have a kind of understanding, how it's kind of multi-threading environment and all that stuff. So those kind of still plays a role in my, my understanding of newer technology, if you will. But I think focus on building a product. I think that's again is something where, leverage the opportunities, focus on the product benefits, the values, as opposed to say, oh, I just have a cooler language, to build this or a faster operating system. But those are not become non-essential, I would think. But you have understanding why it's better, or you don't need to be the expert in this. You don't need to be the best, UI designer. You can actually hire somebody to help you to do that while you figure out what the next product is. I think that will be my advice, a lot of computer science background. And also I would say, that applies to somebody who is not technical. At the same time, to say, well, I don't know operating system, I don't know how to write code and all that stuff. That should not forbid you, say, pursuing that. Focus on the product. All you need is like, maybe you're not again the best designer. You can always hire the best designer. You can always hire a best app developer to help you out to figure out, right? So that's the part where it takes humility, you learn, need to grow because I'm no CEO yet. I cannot afford to hire these people. Well, learn from others. I think this is the part that you want to learn also. Or like technical people can learn from the sort of like, business side of things too, right? So, that's also like, that's why we're all sitting here in the school here.
I actually have one question maybe you have not touched on. So you talked about like the risks about the privacy and getting the data. But when you're investing in these biotechnologies, are there risks associated with the product to market? For instance, if the product needs to go through clinical trials or through FDA approval, so how do you account for that risk? Once these people figure out how to sell, it will take probably years and millions of dollars to push that through.
That's an absolutely great question. There's a lot of risk in those. So that's why it's still we're not in a rosy landscape yet, Yeah, AI solves every problem of the world. Forget about clinical trial, it's gonna work, trust me. No, it's not gonna work. Hopefully it will help achieving those goals, right? So you mentioned clinical trials and all that, right? So I actually took a class from a professor here. His name is Kevin Rock. You might have taken his class. It's a finance class. So one of the things is that they look at like a drug pipeline outcome. The way they deal with it is everything, every milestone, every clinical trials, and they are kind of associated with first a probability of success, and then they associate the financial outcome towards that. Basically, if you look at your kind of portfolio construction, basically it's like you're creating expected value of all this, like what is the potential outcome. If you put a $1 in it, hopefully, because of a success, of reaching clinical trial will be like only 50%. Then your expected outcome is only like 50 cents potentially. So because you can lose that $1, right? We are applying the same framework towards kind of like these companies. So the way we look at it is like there's always a probability, either called risk or success towards that, right? And we pack that kind of like investment down towards it. And that's how we create a framework of how we value some of these companies. So the second question that I think we notice this game is a difficult game. So remember we talk about, well, we tend to look at sort of how the technology, anything that can improve any knobs in between the entire process would be very interesting. So we tend to focus what we call the picks and shovels of the biotech of the life science. What that means is that, well, if you can actually speed up the delivery, the manufacturing process a little bit, that's a good thing, right? So, if you can actually do a better targeting of a person, patient, that's a good thing, right? any technology that allows us to do that, we'll be very interested. So we like to always compare ourselves, that's a becoming cliche, is with the AWS of the biotech. So AWS is the Amazon Web Services. They don't actually provide the website, but they will allow the computer, the server, the memory, the disk and all that, so they can network, so they can put your stuff in there and then just run, right? In a way, we want to do something like that. Although we're not providing servers and all that, but we are doing a lot of different technology, kind of like, facilitator, if you will. Not necessarily from the computer perspective, but also, from the biotech, a lot of these other health delivery systems and all that, kind of and potentially up. And that's how we want to address the risk here. So we're not necessarily wait until the end goal that these guys have to go through the last phase of clinical trial. So a lot of these companies, they provide value to their customers and their clients, the customers. As part of that, they can extract revenue as part of their process. So revenue is part of like how we determine the valuation of the company in a way, right? So if we can actually have that milestones, revenue generated, that basically it's a de-risking factor for us to a lot of these companies. So, and that's why we tend to focus on a lot of these type of, companies where they have a faster exit. Exit by meaning they don't necessarily need to go IPO, they can be acquired because the technology is so promising. Potentially, big pharma can come in and snoop that in, come in and acquire the company. So basically, to us, it's a value proposition in a lot of things. I think the strategies will work out well, and that's how we want to de-risk it. Is a follow how do we handle this stuff here? And I think we have a pretty good track record of working using that strategy. So that's kind of like the first thing I usually tend to compare is that we're not like a drug company. We're not developer. We don't invest in a drug therapeutics company because to me that's a lot of risk involved. What if we can actually kind of break it down into smaller subsets, milestone that can improve? These are the type of company that we're very interested in, and that's how we want to kind of de-risking a lot of these companies.
Yeah. So I think at this point maybe we can thank Darwin again.
Thank you.